Hello everyone, welcome to my channel and today we have to discuss second PUC preparatory exam physics paper. Okay, so we have to discuss first of all, you have to come first time in my channel, then please subscribe my channel and share to their friends. And okay, we have to discuss today physics preparatory paper first. So now this is the paper of KCET exam 2025-26 second PUC preparatory exam. So we have to discuss the paper. First of all, pick the correct option among the four given option for all of the following question. तो देखिए आपको ये questions you have to given these questions and you give the correct answer to all these questions. So question number first is we have to discuss about question number 1. Today we have to zoom all these questions so you see clearly right now. Okay. So first question we have to discuss question number 1. The expression for electric field at point due to infinitely line charge is their usual meaning. Symbol have their usual meaning. So electric field due to the line charge, we know that its formula is E is equal to 2k lambda by r. What is 2k lambda by r? And if we have to put the value of k is what? 1 upon 4 pi epsilon naught. So k is equal to 1 upon 4 pi epsilon naught. Okay, so now here we have to put the value of k. So it is 2 upon 4 pi epsilon naught lambda by r. Okay, so now 2 and 2 2s are 4. So electric field is what? 1 upon 2 pi epsilon naught into lambda by r. So option number B is correct. Equal to lambda upon 2 pi epsilon naught into r. Clear hai? Now we have to move next question. Next question is when a conductor having cavity is placed in electrostatic field, the electric field inside the cavity is 0. Electric field inside the cavity is 0. This is called electrostatic shielding. Okay, this is called as electrostatic shielding. Now next is the temperature decreases the resistivity of on decreasing the temperature. We know that resistance R equal to ml upon Ne square tau A, and resistance is inversely proportional to relaxation time. So on decreasing the temperature, relaxation time decreases, hence resistance and resistivity on decreasing the temperature, resistance and resistivity of metal. अब temperature को decrease करेंगे तो यहाँ पे क्या होगा? In this situation on decreasing the temperature, resistance increases. So metal में in case of metal resistance increases, and semiconductor resistance and resistivity we have to discuss. So now metal decreases, resistivity of metal क्या decreases, and semiconductor increases. Option number D is correct. Clear? Next question is a galvanometer can be converted into voltmeter by connecting high resistance in series with it. Clear hai? Okay. So now pick out the correct statement about bar magnet among the following. Whenever a bar magnet is suspended freely, then it is always stay in north-south direction. So option number B is correct. Lenz law signify the law of conservation of what? Energy. Option number C is correct. The power factor cos phi is equal to 0 in an AC circuit containing only inductor, capacitor and resistor, inductor and resistor, and only resistor. So cos phi is equal to 0. That is, we can say that cos phi is equal to 0. That is, phi is equal to cos inverse of 0. And it is 0 when phi equal to pi by 2. That is, phase difference between voltage and current is pi by 2. And this is happen only in inductor or capacitor. Inductor or capacitor. So your option number first is correct. This will happen only in inductor or capacitor. Capacitor. So we can say that here option number A is correct. Next question is displacement current is the current due to time varying magnetic field, charge moving through a conducting wire, charges moving with constant speed, and time varying electric field. So option number D is correct. It is due to the time varying electric field. Clear to you? So these are all multiple type question. Next MCQs is question number 9. So we have to discuss the graph representing the variation of angle of deviation delta and angle of incidence for a prism. Okay, so for a triangular prism, the relation between angle of deviation and angle of incidence, so we have to obtain the graph C, because by the prism we know that delta equal to I plus E minus A. Okay, so we obtain such type of graph. Next question is, when light passes through narrow hole, it turns corner and enters shadow region. This effect is called diffraction of light. So option number B is correct. Clear to you? Next one is, if unpolarized light of intensity I naught pass through a Polaroid, then the intensity emerges through the light is. So option number A is correct, I naught by 2. Next is, in the following table, the column first is the list of types of electron emission and column 2 is the mode of energy supply for the process. So thermionic emission, when heat is given, then thermionic emission will take place. Electric field emission takes place when electrical energy is given, and photoelectric emission takes place when light energy is given. So that is, we can say that thermionic emission, that is heat energy. So first is R, that is A, and C is incorrect. Second one is field emission is P. So we can say that option number D is correct. Clear to you? Now we move next question. Question number 13 is, in alpha scattering experiment, an alpha particle rebound back along the same path. Then B is the impact parameter and theta is the angle of scattering. So here, this is the nucleus of an atom and this is the alpha particle. For those alpha particle which move along the direction of nucleus, then they return back to the same path. That is, theta is equal to 180 degree. So we can say that option C incorrect and option B is also incorrect. Okay, and when it return back to the same path, then the distance become 0. Impact parameter is 0. So option number A is correct. Isotones are the nuclei having same number of neutrons. Okay, option number D is correct. Next one is, an example of trivalent impurity. So arsenic, antimony and phosphorus all are pentavalent and only one trivalent impurity is boron. So these are the MCQs in your paper. Now we have to move next question. Next question is, fill in the blanks by choosing appropriate answer given in the bracket for all of the following questions. Okay, now we have to discuss first 16, magnetic susceptibility of ferromagnetic material. It is always positive. Magnetic susceptibility of ferromagnetic material is taken always positive. Mechanical energy is converted into electrical energy. Which device convert mechanical energy into electrical energy? So AC generator. AC generator. It convert mechanical energy into electrical energy. The device which work on the principle of mutual induction. Transformer. Transformer work on the principle of mutual induction. So it is transformer. Okay, transformer work on the principle of mutual induction. Reflecting telescope used concave mirror. Concave mirror. Next one is, during interference of radiation. So last one is matter. Next one is what? Matter. Okay, so 16 is positive. This is AC generator, transformer. 19 is reflecting telescope use concave mirror, and during interaction of radiation with exhibits matter. Okay, these are your how much? So these are 5 into 1. So 1, 2, 3, 4, 5. All is correct. Here we don't use negative. Okay. Now we have to move next question. Next question is what? State and explain Coulomb's law in electrostatic. Okay, very simple. 2 marks question. Coulomb's law in electrostatic. We know that these are the two charges Q1 and Q2 placed at very r distance apart. These are placed at r distance apart. So according to this law, the force of attraction or repulsion between any two static point charges is directly proportional to product of magnitude of charge and inversely proportional to square of distance between the charges. Equation number 2. So from first equation and second equation we write it is F proportional to Q1 Q2 by R square, and when we remove here proportionality sign, then we take a constant. So here F is equal to K Q1 Q2 by R square. And what is the value of K? So K is 1 upon 4 pi epsilon. naught. So it is 1 upon 4 pi epsilon naught into q1 q2 by r square. This is the Coulomb's law. Clear to you? So state and explain Coulomb's law in electrostatic. So we have to write first statement. According to this law, the force of attraction or repulsion between any two static point charges is directly proportional to product of magnitude of charge and inversely proportional to square of distance between the charges. And this is the expression. Clear to you? Now we have to move in next question. What is an equipotential surface? And draw equipotential surface for a point charge. Okay, so we have to discuss about the equipotential surface, the surface at which potential is same at each and every point. What is the definition of equipotential surface? Equipotential surface. So equipotential surface is the surface at which potential is same at each and every point, same potential. Okay, at each and every point is called as equipotential surface. You have to draw the equipotential surface due to the point charge. This is asked in the question. We have to draw the equipotential surface due to the point charge. So let's say this is the point charge, and we know that electric field intensity to point charge is always away from the charge. So this is away. This is also away from the positive charge. This is also away from the positive charge. Away from the positive charge. This direction is always away from positive charge, away from positive charge, away from positive charge, and this is also away from the positive charge. Now here we have to draw the equipotential surface due to this point charge. So now this is the circle. Okay, spheres like this. These are the equipotential surface. So we have to draw the equipotential surface due to the point charge. Clear to you? So question is what? Question is what is the equipotential surface? Draw equipotential surface for the point charge. Next question is mention any two limitations of Ohm's law. So what is the limitation of Ohm's law? We have to discuss about. Next one is what? Limitation of Ohm's law. So first one is Ohm's law is not applicable at high temperature because at high temperature V is not directly proportional to I, and the graph between voltage and current is not a straight line, but it bend up to certain instant. First of all, we obtain the straight line like this, but at very high temperature, graph initially at a straight line and after then they become the curve. So we can say that Ohm's law is not applicable at very high temperature. First limitation is. Second limitation is what? Ohm's law is not applicable for electronic devices like diode, transistor, etc. Okay, so this is the second limitation of Ohm's law. Now move next question. Next question is when is the force on the charged particle moving in a uniform magnetic field maximum and zero? So first of all, we know that the force act on the charged particle in uniform magnetic field is the force act on the charged particle in uniform magnetic field is, what is the force on charged particle? F is equal to BQV sine theta. This is the force on the charged particle. V is the uniform magnetic field, Q is the charge of charged particle, and V is the speed of the charged particle. So first of all, we know that when it is maximum, so when there is sine theta, then the maximum value of sine theta is often only at 90 degree. Theta is equal to 90 degree. So what is the maximum force act on the charged particle? F maximum is equal to BQV sine 90. And what is the value of sine 90? 1. So maximum force is VQV. Next, second one is minimum. When it is minimum, so it is minimum when theta is equal to what? 0 degree. When theta is equal to 0 degree, because the minimum, we have to calculate the minimum force. So theta equal to 0 degree. So force F is equal to BQV sine 0. And what is the value of sine 0? Sine 0 is 0. So this is the value of minimum force. Clear to you? Next, we have to move next question. Next question is the magnetic flux. Question number 25. Magnetic flux linked with the coil changes from 5 into 10 to the power minus 3 Weber to 3 into 10 to the power minus 3 Weber in 0.1 second. Calculate the magnetic of induced EMF in the coil. Magnitude of induced EMF in the coil. We have to calculate. This is not magnetic. This is magnitude of induced EMF in the coil. Okay. So we have to write you have to given that in the question is phi 1 5 into 10 to the power minus 3 Weber and phi 2 is equal to 3 into 10 to the power minus 3 Weber in time delta t. Magnitude of induced EMF we have to calculate it. So what is the magnitude of induced EMF? It is E equal to delta phi by delta t. Okay, what it is? Delta phi by delta t. So we have to write here magnitude is phi 2 minus phi 1 divided by delta t. Clear to you? Now we have to calculate the magnitude. So it is E is equal to, what do you mean by phi 2? It is 3 into 10 to the power minus 3 minus phi 1 is what? 5 into 10 to the power minus 3 divided by delta t, and it is 0.01. Now we have to apply the mod. On subtracting, we get it is minus 2 into 10 to the power minus 3 divided by 0.01. This is the magnitude. And when we remove this mod, so we get it is EMF equal to 2 into 10 to the power minus 3 divided by 0.01. On eliminating the decimal, we get here 100. Clear to you? So now it is E is equal to 2 into 10 to the power minus 1. We have to cancel this, then we get 10 to the power minus 1. This is the EMF volt, or we can write here 0.2 volt. This is the answer. Clear to you? Now move to next question. Next question is what? Next question is name the electromagnetic wave produced by. Okay, so electromagnetic wave produced by, first one is accelerated motion of charge in conducting wire, that is infrared ray IR, or next one is hot body molecule. This is also infrared ray IR. Okay, infrared radiation. Next one is write the expression for radius of nth orbit of electron and hydrogen atom. Explain the terms. Okay, expression for nth orbit of hydrogen atom and explain the terms. इसको हमको we have to calculate here in nth orbit what is the radius. Okay, so we write here radius in the nth orbit of hydrogen atom, and it is what? Right, we write here the radius, the value of radius in nth term of hydrogen atom Rn is equal to n square h square epsilon naught divided by pi m z e square. This is the radius, but here n is the number of orbit, h is Planck constant 6.62 10 to the power minus 34, epsilon naught is 8.85 10 to the power minus 12, pi is constant 3.14, m is the mass of electron 9.1 10 to the power minus 31 kg, z atomic number, and for hydrogen it is 1, and in nth orbit of hydrogen atom, and here is charge of electron. So we have to put all these values of constant, we get it is 0.529 n square by z. Z is also 1. So this is the radius in nth orbit. Unit is angstrom. Clear hai? Clear to you? Okay, and explain the terms. So we have to explain here all the terms. N equal to number of orbit, h is Planck constant, epsilon naught permittivity for air or free space, pi constant, m mass of electron, z is what? Atomic number, and E is what? Charge of electron. Okay, next one is name the majority and minority charge carrier in p type. Here in p type semiconductor we doped trivalent impurity. We doped trivalent impurity, and when we dope the trivalent impurity in p type semiconductor, then majority charge carrier is hole. Majority charge carrier is holes, and minority charge carrier is electron. Okay, clear to you? So this is the question number 28. Now we have to move next question. Next question is what? Here we write next question, part C. Okay, and each question carrying 3 marks. Clear to you? Next, write the 3 basic property of electric charge. It is very simple question. The 3 basic property of electric charge is, first one is charge are additive in nature. First property is what? Charge additive in nature. Second, charge follow principle of quantization, that is Q is equal to NE. You know Q equal to NE. So first property is additive in nature. follow the principle of quantization, and third one is follow conservation of charge. Conservation of charge. Okay, here we have to write what? Conservation of charge. Conservation of charge. Okay, so these are the basic properties of charge. Next one is derive the expression for effective capacitance of two capacitors connected in parallel. Here we have to derive effective capacitance of two capacitors connected in parallel. So we write here, let me consider question number, this is question number 30. Question number 30. Let me consider that these are the two capacitors connected in parallel across V voltage source. First one is this and second one is this. These are the two capacitors connected in parallel across V voltage source. This is the voltage source. Okay, clear to you? Okay, we have to draw this diagram in next page. So we have to calculate equivalent capacitance when two capacitors are connected in parallel. So we have to write here, these are the two capacitors. First one is this, second one is this. When these capacitors are connected in parallel across V voltage source, here you have to given that effective capacitance of two capacitors are connected in parallel. Okay, so now this is the voltage source and these are the two capacitors having capacity what? C1 and C2. This is C1, this is C2 and voltage is V. When these capacitors are connected in parallel, so in parallel voltage remains constant and charge divide. So this charge is Q1 and this is Q2. So what is the total charge of the combination? Here we have to write the total charge of the combination is Q is equal to Q1 plus Q2, and by we know that Q is equal to what? CB. So here because in parallel voltage remains constant and voltage remains constant, so it is C equivalent into V. This is C1V plus C2V because V is constant. So here C equivalent V equal to C1 plus C2, and here we have to take an V common. Now we cancel V and V. So what is the equivalent capacity in parallel? So it is C equivalent is equal to what? C1 plus C2. This is your final result. Clear to you? Now we move next question. Next question is what? Using Ampere circuital law, obtain the expression for magnetic field at a point due to infinitely long straight conductor carrying current. We have to calculate the magnetic field due to current carrying straight conductor infinitely long by using the Ampere circuital law. Okay, so this is next question number 31. This is very important questions. All these questions are very important to you, so you have to learn very keenly. Okay, now we have to take on here infinitely long. This is a infinitely long current carrying conductor. These are the infinitely long current carrying conductor carrying current I in upward direction, in which we have to take a certain element in the conductor. Okay, this is the current carrying conductor carrying current I in upward direction. Then we know that by right hand rule, thumb shows the direction of current and finger indicating, and the direction in which finger rules is the direction of magnetic field. So here the direction of magnetic field is like this. Okay, what is the direction of magnetic field? This is the direction of magnetic field inside the conductor, and you have to give in here the radius is r. This radius is r, and we determine the magnetic field at this point P. Okay, and according to Ampere circuital law, the direction of magnetic field at any point due to small element, and this loop is called Amperian loop. This is the element AB having length dl. We have to calculate the magnetic field due to small element of length dl. Okay, this is the length dl, and according to Ampere circuital law, the direction of magnetic field at any point is always tangential to the loop. Is always tangential to the loop. This is B vector. So the direction of magnetic field is tangential. Then we know that by Ampere circuital law, the line integral of magnetic field in a closed path, line integral of magnetic field in a closed path is equal to mu naught times to the summation of total current flowing in the closed loop. Clear to you? So here, a small element and magnetic field both are in same direction. So angle is 0 degree, and when we remove this dot product, then we get cos theta. So it is BDL cos 0 is equal to mu naught. And what is sigma I? Current enclosed by the closed Amperian loop. This is the closed loop. Okay, so current enclosed is I. Here B is constant, and we have to integrate with respect to dl is equal to mu naught into I. What is dl? Line integral, and there the line integral is the circumference of this Amperian loop. This is the circumference of this Amperian loop. So it is 2 pi r. B into 2 pi r is equal to mu naught into I. So what is the magnetic field? It is B equal to mu naught I upon 2 pi r. This is your final result. So magnetic field due to infinitely long current carrying conductor by using the Ampere circuital law. Okay, next. Question number 32. State and explain Gauss law in magnetism and give its significance. So Gauss law in magnetism state that question number 32. This is question number 32. What is the significance of this law? So Gauss law in magnetism state that the surface integration of magnetic field in a closed magnetic path is always equal to 0. What is the Gauss law in magnetism? According to this law, the surface integration of magnetic field in closed magnetic surface is always equal to 0. So what is the significance of this law? This law states that the amount of magnetic field of lines entering to any closed loop is always equal to the number of magnetic field lines leaving to this closed loop. Hence we can say that the magnetic monopole does not exist. Okay, but electric monocharge can exist, but magnetic monopole does not exist. This is the significance of Gauss law in magnetism. Clear to you? Next question, derive the expression for energy stored in current carrying inductor. We have to derive the energy stored in current carrying inductor. Question number 33. Okay, now, so we write here question number 33. What is the question number 33? You have to derive an expression for energy stored in inductor. So now here we have to consider an inductor when I current pass through the inductor having self inductance L. Whenever the I current pass in the inductor, then EMF is induced in it, which opposes the flow of current. So to flow the current in this inductor, flow of I current in the inductor, external work is to be done. Because when current is passed in this inductor, then EMF is induced in it. Induced EMF produced in it due to change in magnetic field. Time varying. If this current changes with time, then magnetic field is induced in it. So what will be the work done? So here we write the power of inductor is power P equal to E into I. Okay, this is the equation number 1. We get this relation from power P equal to VI. Here the EMF across the end of inductor is capital E. So it is power P equal to E into I. Clear to you? Okay. Now, what is the power? So we know that power equal to dW by dt. Clear to you? Rate of amount of work done. So dW equal to what? P dt. And now we write the value of power. So power equal to EI into dt. And what is the magnitude of induced EMF in inductor? So the magnitude of induced EMF in inductor E equal to L di upon dt. Di by dt. We write here dW is equal to magnitude of EMF of inductor is L di by dt multiplied by I dt. Here we cancel dt and dt. So we write here Li di. What is the work done? So work done is what? dW is equal to what? Li di. Okay, clear to you? On integrating both the side of the equation, so integration of dW equal to integration of Li di. When current in the circuit is 0, work done is 0 to flow the current. When I current is passed in the inductor, then work done is W. So what is the integration of dW? It is W limit 0 to W. Here L is constant, and integration of what? I di, and here limit is 0 to I. Okay, clear to you? Now we have to put the limit, upper limit minus lower limit, w minus 0 is equal to L. Here the integration of I is I square by 2 and limit is 0 to I. Clear to you? So w minus 0, we get here w is equal to L, and here we have to put the limit I square by 2 minus 0 square by 2, so this is 0. Okay, now we get multiplied here. When we multiplied the term, we get work done is equal to half Li square, and we know that work done equal to potential energy here. So we get the potential energy stored in inductor U equal to half Li square. This is your relation. Clear to you? Okay, now we have to move in next question. Next question is what? Next question is so that radius of curvature of a spherical mirror is equal to twice of focal length. We have to show that the radius of curvature of spherical mirror is equal to twice of focal length. Okay, so we have to find the relation between what? E and relation between f equal to r by 2, and here r equal to 2f, that is radius of curvature is 2 times of focal length. This relation we have to prove. Clear to you? Now we have to prove this equation. So we get a spherical mirror. Let's say this is the concave mirror having pole P, focal length f, and radius of focal length f. So let's say this is the principal axis and P is the pole. This is the principal axis. P is the what? Pole. A light ray incident parallel to principal axis of the mirror, and after reflection from mirror, it passed through focus. And this definition is true only for the paraxial rays. What is the paraxial rays? The light ray which incident very close to the pole. Okay, this information is very important. The light ray which incident very close to the pole is called paraxial rays. This is the focus. Now we have to join a line from center of curvature. This is the point on the center of curvature C. So let's say this is the center of curvature C. And the line joining the center of curvature to their circumference is a perpendicular on this spherical surface. So the angle between this perpendicular and incident ray is called as angle of incidence I. And the angle between reflected ray and normal is called angle of reflection R. We have to prove here this relation. So now we have to give in, this is let's say what, this point be x, this is y. Okay, so we have to prove in, we get here angle XYC. What we write here? We have to write, let a concave mirror, a light ray XY is incident parallel to the principal axis, after reflection from mirror pass through focus. So here we get angle XYC, angle XYC, sorry, here we get angle XYC equal to CYF, angle CYF. How it is? By law of reflection, incident ray is always equal to reflected ray. So we write this relation by law of reflection, by law of reflection. Clear to you? This is true by law of reflection. Now after then we write here angle YCF, YCF. This is the angle YCF is equal to just 1 minute. First we write here angle XYC. What? Angle XYC. This is the angle XYC is equal to angle YCF. YCF. Okay, this is XYC equal to YCF, like this Z. And these angle are equal by alternating interior angle. So this is also I. So this is equal by alternating angle. By alternating angle. Clear to you? This is by alternating angle we write here both are equal. Now So we have to find this triangle. So in triangle CYF, we write here in triangle CYF. Okay, this is the triangle CYF. And by in a triangle, these two angles are equal by law of reflection. By law of reflection. By law of reflection. So here we get by the law of reflection, both these angles are equal. Clear to you? Both these angles are equal. Which angle are equal? Angle CYF. Angle CYF. This is CYF is equal to, or we can write here angle YCF first. YCF is equal to CYF is equal to angle CYF by law of reflection. That is angle I is equal to angle R. And we know that by property of triangle, if two angle of a triangles are equal, then their corresponding opposite sides are also equal. So this is the angle I and their opposite side is YF, and this angle is R, opposite side is CF. These are equal. So we write here what is I? I is YF, and what is R? R is CF. Clear to you? But in case of mirror, all the distances are measured from pole. This is YF and equal to CF. In case of mirror, all the distances are measured from pole. So we get here for paraxial rays. For paraxial rays. Paraxial rays is those light ray which incident very close to the pole. So that is Y is nearly equal to P, because this light ray incident very close to the pole, so Y is nearly equal to P. And what is the Y? Y is PF is equal to CF. And we know that all distances are measured from pole, so this is from pole. And CF we write here from the pole. So PF equal to CF. What is the value of CF? PC minus PF. It is PC minus PF. PC minus PF is equal to CF. Okay, all the distances are measured from the pole. And we write here PF plus PF is equal to PC. This PF can be transferred from there. So this is PF plus PF equal to PC, and this is 2PF equal to PC. And by using sign convention, all the distances are measured from the direction of incident light. This is the direction of incident light. And PF we measured in opposite direction, and the distance between pole and focus is called focal length. And distance between center of curvature and focus is called radius of curvature R. Clear to you? So light rays incident like this, and we distance measured in opposite direction of light. So what is PF? PF is equal to minus F. And what is PC? Minus R. So we write here 2, or PF is minus F and PC is minus R. So minus 2F is equal to minus R. This minus and minus cancel. So we can say that 2F equal to R. This is the relation between focal length and radius of curvature for spherical mirror. Clear to you? Now move next question. So that the radius of curvature of spherical mirror is equal to twice of the focal length. Next one is mention any three experimental result of photoelectric effect. Three experimental result of photoelectric effect. So this is the theoretical question, and the experimental result of photoelectric effect is, first one is what? First one is in photoelectric effect, the incident light radiation, या radiation of incident light, या ऐसा बोल सकते हैं आप, you have to discuss that intensity, okay, directly proportional to number of photoelectron emitted per second from the emitter plate. Intensity of incident radiation at constant frequency and constant potential difference between collector and emitter plate. Intensity of incident radiation directly proportional to number of photoelectrons emitted per second from the emitter plate, or directly proportional to photocurrent. Photocurrent. This is the first. Second one is, we also know that the intensity is also depend on the saturation current. More is the intensity, more is the saturation current. So second one is what? Intensity proportional to saturation current. Third one is The required a certain minimum frequency below which electron emission will not take place. This frequency is called as threshold frequency. Next one is what? The fourth one. Fourth one is what? The minimum negative potential of collector plate. The minimum negative potential of collector plate for which emission of fastest emitted electron becomes stop and photocurrent in the circuit becomes zero is called stopping potential or cutoff potential. Clear to you? Next, question number 36. But the binding energy of alpha particle is given to you from following data. Mass of the alpha particle is this, mass of the neutron is this, and mass of proton. You have to calculate the binding energy. Okay, so we have to discuss what will be the binding energy. So here you have to give in this the data. This is alpha particle 2He4 and mass of alpha particle is this, mass of neutron is this, mass of proton is this. First of all, we write here mass defect delta m. So mass defect delta m equal to ZMP minus plus A minus Z into Mn. Clear to you? Minus actual mass of the nuclei, capital M. This is the mass defect. Clear to you? That is, this is the actual mass of the alpha particle. Okay. Okay. This is the actual mass of the alpha particle, M alpha. Now, we write here delta M is equal to Z. What is Z? Z is the atomic number. So it is 2. And what is A? Is the mass number. So mass number is what? Mass number is 4. Clear to you? So Z. What is Z? 2 into MP. Mass of proton 1.007825. Clear to you? Plus A minus Z. That is 4 minus 2. So it is also 2 into Mn. Mn is what? 1.008662. This is given to you in the question. This data is given to you in the question. What is the actual mass of the alpha particle? So minus 4.00260. Okay. Now we multiply. This is 0, 4 or 1, 5. This is 16 and 14 or 1, 15. 2.015650 plus this is what? This is 4, 2, 3, 1, 17 and this is 2.017 minus 4.00260. Now we calculate this. After then we get the mass defect delta M. Clear to you? So delta M is equal to what? So we write here, this is 2.015, okay, 650. And this is what? 2.017324 plus we get here 4, 7, 9, 12, 1, 2, 3, 0, 4 point this. And we subtracted 4.00260 minus. So we get here 4, 7, 3, 0, 3, 0, 0 point this. So mass defect is 0.030374. This is the mass defect. And we calculate here the binding energy, EB. And binding energy equal to delta M into C square. Okay. This is in unit. And we know that 1 unit is equal to what? 1 U equal to 931.5 MEB per C square. Okay. So, okay. 0.030374 into what is 1 U? 1 U is what? 931.5. This is the standard relation. So, this is into C MEB mega electron volt per C square. And this is the C square. So, multiplied with C square. C square and C square cancel. On multiplying this, we get the final answer. Clear to you? On multiplying that data, we get the final answer. Clear to you? So this is the numerical. And here we get, this is the calculate the binding energy. Question number 36. Now we have to move next question. Next one is question number 37. 37 question is what? It is derive the expression for electric potential at a point due to point charge. We have to derive the expression for electric potential at any point due to the point charge. Clear to you? Okay. So we have to derive the expression for electric potential due to the point charge. Let we have to consider a point O at which plus Q charge is placed, and from point O at a distance small r, a point P is situated. Okay. Now at certain distance, these are the 2 points. This is the point B and this is the point A, and let's say this is the infinity. Let this is the distance be dx. Clear to you? And the separation between point O and A be x, and a point charge q naught, test charge q naught is placed at point infinity. When it is placed at infinity, then force becomes 0 because F equal to K Q1 Q2 by R square. R is infinity, so force is 0. But whenever this charge is placed at point A, so it repel with the force F, electrostatic force F. But whenever this charge Q naught is bring from point A to B, that is in displacement direction is A to B. Force and displacement both are opposite. So what is the work done to bring this test charge Q naught from point A to B? So this work done is dW is equal to F dx cos theta. Cos theta is what? Cos 180. Because this force and displacement both are in opposite direction, so it is 180 degree. And cos 180 is -1, so work done is dW is equal to minus F into dx. Clear to you? What is the force between these two charges? So force is F equal to K Q1 capital Q, Q2 Q naught by R square, that is it is x square. So we put this value, then work done is dW equal to minus K Q naught capital Q upon x square into dx. Then to calculate the total work done when a charge is bring from infinity to this point P, then on integrating both sides. So integration of dW is equal to integration of minus K Q naught capital Q divided by x square dx. Initially, here we have to integrate with respect to x, and here we have to integrate with respect to work done W. So now, initially, the test charge is at infinity. So work done is 0 because force is 0. When it is bring from infinity to this point P, then the distance is R with respect to O, and work done is W. Integration of dW is what? So we know that integration of dW is W, and limit is 0 to W is equal to dx. We have to integrate with respect to dx. So this is constant minus K Q naught capital Q. This is constant, and integrate with respect to 1 upon x square into dx, and limit is infinity to R. On integrating, we have to put the limit, upper limit minus lower limit. So W minus 0 is equal to minus K Q naught capital Q, and it is x to the power minus 2 dx, and limit is infinity to R. Clear to you? Here we have to apply the formula x to the power n. So work done W is equal to minus K Q naught capital Q, here x to the power minus 2 plus 1 upon minus 2 plus 1, and this is infinity to small r. Clear to you? Now W is equal to minus K Q naught capital Q, and it is x to the power minus 1 upon minus 1 infinity to R, and this minus and minus cancel. So work done is what? W equal to K Q naught capital Q, this is 1 by x infinity to R. Clear to you? Now on solving, we get by putting the limit, so it is W is equal to K Q naught capital Q. Here we have to put the upper limit, and upper limit is what? R. So it is 1 upon R minus 1 upon infinity, and 1 upon infinity is what? 0. So work done is W is equal to K Q naught capital Q by R. We have to calculate potential. So by definition of potential, work done to bring a unit positive charge from infinity. So this is V is equal to W. W is what? K Q naught capital Q by q naught into r, and this is cancelled, so potential is v equal to kq by r. This is the formula of potential due to the point charge. We have to write here. Now, next question is, assuming the expression of drift velocity, derive the expression for conductivity of material. Sigma is equal to Ne square, this is tau, Ne square tau by m, where symbol have their usual meaning. Clear hai? Symbols have their usual meaning. Okay, we have to prove that sigma equal to n square tau by m. Sigma equal to n square tau by m. Sigma is equal to ne square tau by m. Assume the drift velocity. So let's say we consider that here this is a conductor and I current is flowing through the conductor, and V is the potential difference is applied across the end of the conductor. Okay, plus minus the length of the conductor is L and area of cross section is A. When potential difference is applied across the end of conductor, then electrons start moving from negative terminal to positive terminal like this with drift velocity Vd. What is the drift velocity? Vd. So relation between electric current and drift velocity I equal to Na Vd E. This is the relation between electric current and drift velocity. And in the question, you have to given that assume drift velocity. So it is E tau by m. This is the formula of drift velocity. What is the formula of drift velocity? E tau by m, where E is charge of electron, electric field, relaxation time, and this is mass. We have to put here all the values. So I is equal to Na, and what is Vd? Vd is E tau by m into E. Clear to you? Okay. Here we have to write I upon A equal to n into small e capital E tau by m into E. On multiply we get here I by A is what? Current density, J equal to I by A. This is called what? Current density. So current density J equal to N E square tau by M into capital E. Okay. Here we have to write what? J by E is equal to Ne square tau by M. And we know that microscopic form of Ohm's law, J equal to sigma E. So J upon E is equal to what? Sigma. So this is sigma is equal to Ne square tau by M. This is the relation we have to prove. Ne square tau by M with the help of a relation between electric current and drift velocity. Next question is what? Often the expression for force per unit length between two infinitely long straight parallel conductor carrying current and placed in vacuum. Carrying current and placed in vacuum. What is the nature of force between two conductors if current are in opposite direction? Current is flows in opposite direction. Question number 39. Okay. So we have to discuss here question number 39. Current is in opposite direction. Okay. Just 1 minute. You have to give in that current flows in opposite direction. So these are two finitely long straight parallel current carrying conductor. Infinitely long. These are the two infinitely long straight current carrying conductor. Clear to you? Okay, just 1 minute. You have to give in that these are the two parallel current carrying conductor carrying current in opposite direction. This is given to you in the question. So now here this is first conductor and this is the second conductor, and both the conductor carrying current in opposite direction. So it carry current I1 and this conductor carry current I2, and both conductor are placed at d distance apart. Clear to you? Consider two infinitely long parallel current carrying conductor carrying current I1 and I2 in opposite direction. Because the condition is that current flows in both the conductor in opposite direction. You have to give in that current what is the nature of force if current flows in opposite direction? This is the given to you. Current will flows in opposite direction. Clear to you? Okay. So now this current is flowing in opposite direction. First of all, we have to apply by Fleming right hand rule. And Fleming, first of all, we apply palm rule, right hand palm rule. Right hand palm rule. Thumb shows the direction of current and finger indicating the point at which magnetic field is to be determined. Okay? Because when I1 current is passed in first conductor, then it produces a magnetic field. And when it produces a magnetic field, then what is the value of magnetic field at second conductor, at point of second conductor due to first conductor? So thumb shows the direction of current and finger indicating the point. So magnetic field is inward. This is the direction of magnetic field inward. And in this condition, thumb shows the direction of current and finger indicating the point. So again, magnetic field, direction of magnetic field is inward. Clear to you? Clear to you? This is the direction of magnetic current, and this is the point at which magnetic field is to be determined due to second conductor. This is first conductor, and this is second conductor. So magnetic field on the surface of second conductor due to current of first conductor, inward. Magnetic field on the surface of first conductor due to current of second conductor. So it is also inward. Now we have to determine the value of forces. Now, by right hand rule, thumb shows the direction of current and finger indicating the direction of magnetic field. Magnetic field inward or thumb is upward. Current is upward. Force is away. Like this. Force is away. And the value of force is F vector 2 1. F vector 1 2. Force on first due to second. F vector 1 2. Here also magnetic field is inward and current is downward. Force is away. So this is F vector 2 1. Force on second due to first. Okay. What is the magnetic field produced by when I1 current is passed in first conductor? I1 current is passed in first conductor. Then magnetic field produced by first conductor at distance d. So we write here value of magnetic field is B1 is equal to what? Mu naught I divided by, this is mu naught I divided by I1 divided by 2 pi d. This is the magnetic field produced by first conductor on the surface of second conductor, and this second conductor is placed in the magnetic field of first conductor. This second conductor is placed in the magnetic field of first conductor. So what is the force act on the second conductor due to magnetic field of first conductor? F21 is equal to, what is the force on current carrying conductor? BIL. So B1 current is what? I2 into L. This is the force. We have to put the value of B1. So F21 is equal to mu naught I1 divided by 2 pi d into I2 into L. But we have to calculate here force per unit length. So it is F21 by L is equal to mu naught I1 I2 upon 2 pi d. In this situation, we have to multiply it and divide it by 2 in numerator and denominator. So it is F21 by L equal to 2 mu naught I1 I2 upon 4 pi d. 4 pi d, and mu naught upon 4 pi, we know that it is 10 to the power minus 7. So this is the force per unit length on the conductor. Similarly, if we have to calculate F12, so it is also 2 mu naught I1 I2 divided by 4 pi d. But the direction of both the force is opposite. So in vector form we write here force per unit length. Okay. So in vector form we write here in vector form we write the value of force. So F vector 1 2 is not equal to F vector 2 1. So both the forces are equal in magnitude but opposite in direction. Clear to you? Then we have to calculate the force per unit length on the conductor. So current in opposite direction. What is the nature of force? Opposite, equal in magnitude, opposite in direction. Next one is, what is the wave front? You have to understand what do you mean by the wave front. So wave front is the imaginary surface drawn at any instant when all the particle of medium is vibrate in the same phase. Let's say we have to take on a point from which this is the point source and it releases the light energy in all possible direction like this, and at any instant we have to draw an imaginary surface at which all the particle of medium vibrate in the same phase, and this is called as what? Wavefront. Clear to you? State Huygens principle and using the same so that angle of incidence is equal to the angle of reflection during the reflection of plane wavefront by plane surface. Clear? ये हमको प्रूफ करना है, ये this is we have to prove. So state principle of Huygens principle. Huygens principle is according to this principle, each point on the primary wavefront will behave as a new light source. What is this principle? Each point on the wavefront will behave as a new light source and they can produce the secondary waves. Okay, this is the Huygens principle. Clear to you? What is the Huygens principle? So each point on the wavefront behaves as a new light source and they can produce the secondary wave in given time interval. Clear to you? We have to prove reflection of light by the plane surface by the theory of wavefront. So here we have to consider that, let's say this is a plane mirror. Let's say this is the plane mirror. Okay, and a plane wavefront is incident on this plane mirror. So this is the plane wavefront AB. Let's say this is the plane wavefront AB is incident on this plane mirror. And according to Huygens theory, each point on the wavefront will behave as a new light source and they can produce the secondary waves. Clear to you? And the ray of light perpendicular to this wavefront, the ray of light perpendicular to this wavefront is called light rays. So first one is this is perpendicular to this wavefront. Second one is this is also perpendicular to this wavefront. Sorry, we have to draw this is the ray of light perpendicular to the wavefront. Also this is the ray of light perpendicular to surface of the wavefront, and this is also the ray of light perpendicular to surface of the wavefront. Let's say here what? This is the wavefront incident on the surface plane surface AB. This is the wavefront incident on the surface AB. Clear to you? Now we have to move in the next concept. Next concept is what? Okay, this is the wavefront, and these are the light ray perpendicular to the surface of the wavefront. This is like this. Clear to you? And this is an angle of incidence I. Okay, this wavefront incident at an angle of incidence I. And according to Huygens principle, each point on the wavefront, so this is also I, each point on the wavefront will behave as a new light source and they can produce the secondary wave. So let's say, and the light ray is always perpendicular to the surface of the wavefront. So let's say the secondary wavelet at point, this is point A and this is the point B. This is point A and this is the point B. So the secondary wavelet at point P travel distance what? C delta T and strike to the plane surface at some point A dash. Okay, at some point A dash. So let's say this is the point A dash and this is the distance C1 delta T. Similarly, the second wavelet at point A also behaves as a new light source and they can also produce the secondary wavefront. So let's say taking A as a center and C delta T as a radius, not C1, same medium, so it is C delta T. So A as a center and C delta T as a radius, we have to draw an arc. We have to put here and draw the arc. And now after the drawing the arc, we have to draw a tangent on this arc from this point A dash. From point A dash, we have to draw the tangent on the arc. So this is the arc. We have to draw the tangent on the arc. Clear to you? We draw the tangent on this arc. And after the tangent on the arc, we join the point A to the point B dash like this. Okay. So this is the point A dash, this is B dash. Clear to you? And this is again advances in such a direction like this. And this is also, we can say here, this is incident on this surface, and after reflection it pass like this. Okay, so this is the surface in which wavefront get advances. We have to prove that angle of incidence is equal to the angle of reflection. Clear to you? Now in this situation we have to also, this is angle R, so this is also angle R. This angle is also R. Now we have to prove the angle of incidence equal to angle of reflection in the wavefront. So we have to take on a triangle A dash, in triangle A dash, A dash, and triangle A dash B dash A dash B dash A. Clear to you? First of all, we can say that A B dash in first triangle, what? A dash. Okay, A dash B is equal to A B dash. Why these are equal? Because each is C delta T. Each C delta T. Each distance is what? C delta T. Clear to you? Now, second one point is, this light ray is perpendicular to the surface of the wavefront, and this is also perpendicular to surface of wavefront. So we can say that angle A B A dash equal to angle A dash B dash A. Why these are equal? A dash B dash A. Why these are equal? Each 90 degree. Each angle is what? 90 degree. Next one is what? We can say here, next property is A dash is equal to A dash is equal to A dash, common side in both the triangle, common. So we can see that by SAS, side angle side congruency, triangle A dash is congruent to triangle what? A dash B dash A is congruent to triangle A dash B dash A. And if these triangle are congruent, then by CPCT, corresponding part of CPCT, corresponding part of congruent triangle, angle BA A dash is equal to what? Angle B dash A dash A. Angle B dash A dash A. So here we can see that angle I is equal to what? Angle R. This is the proof of law of reflection of light by wave theory. Clear to you? Now we have to discuss next question. Next question is 41 question. Question is what? Classify solids into conductors, insulator, and semiconductor on the basis of band theory. And what is the rectifier? Which property of PN junction diode is used as a rectifier? Now, so we have to discuss that what is the energy band of solids to classify the solids. So this is one is, there are the three conditions. First one is for conductor. So in conductor there are two conditions. First one is, this is valence band, and this one is what? Conduction band. And in case of conductor, valence band is fully filled with electron and conduction band is empty, while the forbidden energy gap between valence band and conduction band is very small, nearly 0 electron volt. Or we can say that some part of valence band is overlapping with conduction band and they form a new band called overlapping band. So the forbidden energy gap between valence band and conduction band is very low, and electron easily jump from valence band to the conduction band. And whenever electron easily jump from valence band to conduction band, then they conduct electric current very easily, but at 0 Kelvin temperature they also behave like a insulator. Okay, so Eg nearly equal to 0, okay, in conductor. So electron is always present in this situation in conduction band, and in this situation there is very small forbidden energy gap, so they easily conduct the current. This is called as conductor. Second one is insulator. Insulator. In case of insulator, valence band is completely filled with electron and conduction band is empty, and the forbidden energy gap between valence band and conduction band is greater than 3 electron volt. That is, for diamond it is 6 to 7 electron volt. So the electron present in valence band, by gaining the energy from the external source, then these electrons do not get that much energy, so they will shift from valence band to conduction band. That's why the insulator will not conduct the current. Next situation is for semiconductor. In case of semiconductor, valence band is completely filled with electron and conduction band is empty. While the forbidden energy gap between valence band and conduction band is less than 3 electron volt. That is, for silicon, it is 1.4 silicon. It is 1.12 electron volt, and for germanium, it is 0.72 electron volt. So this is the forbidden energy gap, and whenever the energy is given to these electrons from the external source, then easily move from valence band to conduction band. And whenever the electron reaches to conduction band, then they behave like a free electron. So whenever the electric field is applied, then they conduct the electric current. So these are the classification of conductor, insulator and semiconductor on the basis of band theory. Next question is what? So next question is, what is a rectifier? So rectifier is a device which converts AC into DC, alternating current into direct current. And which property of PN junction diode is used as a rectifier? So PN junction diode is a unidirectional device because they flow current only in forward wise direction, while in reverse wise direction PN junction diode act as a open circuit. Ideal diode act as a open circuit. That's why it is a unidirectional device. This property is used as a rectifier. Clear to you? So this is our section D. Now we have to move last section called section E. This is the section E. In this section, any two of the following question, you have to do any two question, but here we have to solve all the question for you. 2 into 5, 10 marks. Question number 1 is 4-point charges of 6 nanocoulomb, minus 3 nanocoulomb, plus 6 nanocoulomb and plus 3 nanocoulomb are placed respectively at the corner of ABCD of a square of side 0.2 meter. Calculate magnitude and direction of electric field at the center of the square. Clear? This is the question. Clear to you? We have to calculate electric field at the center of the square. So when we calculate the electric field at the center, then we know that electric field intensity is a vector quantity and its direction is always away. So direction is always away from the positive charge. So this is, let's say this is EA, and due to this charge also electric field is away. So this is EC. Okay, and both of the field are equal in magnitude and opposite in direction. Why it is equal in magnitude? Because electric field is what? E equal to KQ by R square. So here charge is plus 6 nanocoulomb equal. Case 9 into 10 to the power 9. And distance. This distance is given to you 0.2 meter. This is what? 0.2 meter. Okay. This is 0.2 meter. So if this is A, then what is the length of the diagonal? Root 2A. And this is the half length from this to this. This is the half length. This segment is half. Half, so root 2A by 2. And A is what? Root 2 into 0.2 divided by 2. So this is 0.1. So 0.1 root 2. Clear to you? So distance is also 0.1 into root 2. This is 0.1 into root 2. Okay. And this is also 0.1 into root 2. So we can say that ki EA is equal to EC, equal in magnitude and opposite in direction. So what is the net intensity due to these A point and C point? Become 0. So E net equal to EA minus EC equal to 0. Next, here you have to give in that electric field intensity due to this plus Q charges away and due to this minus Q charges towards. So this direction is ED and this is EB. So due to these charges, electric field at the center E is equal to E net equal to EB plus ED. And again, this is plus 3, this is minus 3. And due to this minus sign, we have to take on the direction. So this magnitude is 3, this is also 3. Equal in magnitude, and this distance is 0.1 root 2. This is also 0.1 root 2 because we have to find out the electric field at the center. So this field is also same and same. So we write here E2EB because this is EB, 2EB because EB equal to ED. Now, what is the electric field? So electric field is KQ by R square. KQ by R square. We have to write here 2. What is K? K is 9 into 10 to the power 9. What is Q? Q is 3 nanocoulomb. Nanocoulomb is converted into coulomb divided by R square. It is 0.1 into root 2 whole square. Clear to you? Now, again, we have to simplify it. On simplifying the term, we get here 2 into 9 and both these terms are cancelled. Plus 9, minus 9, minus 9 and plus 9 are cancelled. 2 into 9 into 3 and this is 0.1. So we can get 0.01 into 2 and this 2 and 2 is cancelled. 9 3s are 27 and when we remove this decimal, so we get here 10 to the power 2. So 27 into 10 to the power 2 Newton per coulomb. This is the resultant electric field intensity at this center and the direction is along D2B, along DB vector. Clear to you? Okay, we move on next question. Next question is find potential difference across 10 ohm resistor in the following network. In this network, we have to determine the resistance across 10 ohm. Okay, this is the network and we get the resistance across in this 10 ohm. There are so many methods to solve this question, but we have to apply the shortest method because by applying the Kirchhoff's law, Kirchhoff's KVL, it is so lengthy and calculation is so tough because here the data is very tough to solve this question. So we have to solve this question in the simplest manner. So to solve the question in this question in simplest manner, we have to draw one more circuit. This 4 ohm, 1 ohm and 6 ohm all are connected in series in this segment. This current is I2, let's say, and this is I3. We have to calculate this I3 current in the circuit. Okay, this is voltage across 10 ohm. So this 4, 1 and 6, these are connected in series. This all arrangement are connected in series and also this all arrangement are also connected in series. Okay, so now this 4 plus 6, 10 and 2, 12. So we write here this circuit is, this is 12 ohm. Okay, 12 ohm. And what is the voltage? What is 4, 6 or 2? 12 and this is 4 volt. 4 volt plus minus. Okay, now again this resistance is also same and we have to join the circuit. This is 10 ohm and this is the 2 volt plus minus. This is 4 plus 6, 10 and 1, 11 ohm. So this is 11 ohm. Okay, both of these cells are connected in parallel combination across the 10 ohm. So here we have to apply the voltage in parallel. E equivalent is equal to E1 R2 plus E2 R1 divided by R1 plus R2. We have to write here what is E1. E1, let's say this is E1 and this is E2. This is E1 and this is E2. Clear to you? So E1 is what? 4. R2 is 11 plus E2. E2 is what? 2 into R1. R1 is 12 divided by R1 plus R2. That is 12 plus 11. 12 plus 11. Clear to you? So on multiplying we get here 44 plus 24 divided by this is 23. So total result is 68 by 23. 68 by 23. Clear to you? Near about 3 volt. Nearly equal to 3 volt. This term is nearly equal to 3 volt. Clear to you? Okay. Now, again, this is the E equivalent. But in this situation, we also find the R equivalent. So this and this both are connected in parallel because this current move in this direction and this current again moving there. So both of these are connected in parallel, and in parallel what is the equivalent? R1 R2 divided by R1 plus R2. What is R1? R1 is 12 into 11 divided by 12 plus 11. So we get here 22 to 11 or 2 32 by this is 23. Clear to you? This is the R equivalent. Now we have to draw again the equivalent circuit one more time. So the equivalent circuit is here. We have to draw their equivalent circuit. Both these cells are recombined to form a single cell with resistance, and this is also another resistance of 10 ohm. This is the circuit. This is 10 ohm. Clear to you? This is what? This is the 10 ohm. And now here this equivalent EMF is 68 by 23 volt plus minus. This R equivalent is 132 divided by 23, and this is 10 ohm. What is the capital R equivalent? So this is capital R equivalent is 10 plus 132 divided by 23. Okay, 132 by 23. Now here we have to take on the LCM 23. So this is 230 plus 132. On adding the term, we get 362 by 23. This is the R equivalent. We have to calculate the current in the circuit. And what is the current? Current is I equal to V by R equivalent. Okay. So here, what is V? V is 68 by 23. 68 by 23. And what is the R equivalent? 362 divided by 23. This 23 and 23 cancel. So it is 68 by 362. Again, it is very, very tough situation, but we have to calculate the voltage across this 10 volt. So voltage across the 10 ohm, V equal to IR. What is I? I is what? 68 by 362, because in series current remains constant, and what is R? R is 10. So we get here 68 680 by 362. Clear to you? And on dividing it, we get 1.88 volt approx. This is the voltage across this 10 ohm resistance. Clear to you? Now we have to move next question. What is the next question? It is okay. A series LCR circuit containing inductor of 0.194 Henry, capacitance 35 microfarad and resistance of 40 ohm is connected across AC source of 200 volt, 50 hertz. Impedance and power factor of the circuit. You have to calculate impedance and the power factor of the circuit. Okay. So now here we have to calculate the impedance and power factor of the circuit. So to calculate the impedance, first of all, we have to calculate the inductive reactance XL, and XL equal to omega L equal to 2 pi FL or 2 pi nu L. Nu is what? Frequency. So here you have to given that 2 into what is pi? Pi is 22 by 7. Frequency is 50 and L is what? 0.194 Henry. Clear to you? We have to multiply 50 to the 100, and 100 multiplies 19.4 into 22 by 7. Clear to you? Okay. On solving, we get XL is nearly equal to 61 ohm. On solving this is, we get it is 61 ohm because it is 7 to the 14 and this is 54. Okay, so on solving it is 60.8 approx, so it is 61 ohm. Now we have to calculate XC, and what is XC? 1 upon omega C, and omega is what? 1 upon 2 pi nu C. Now we have to put the value. So x equal to 1 upon 2. Pi is what? 22 by 7. And what is frequency? 50. And c is what? 35 into 10 to the power minus 6. So again on solving the term, 50 to the 100, this is 10 to the power minus 4, and minus 4 is taken in up. So it is 10 to the power 4 and 7 5 ja. So 22 into 5. Clear to you? So this is 10,000 divided by 5 to the 10, 11 and 10. 0 and 0 cancel. So this is 11 9 ja, 99. So it is 90.9. So near about 91 ohm. Clear to you? This is XL 61 ohm. This is XC 91 ohm. You have to calculate the impedance of the circuit. And when you have to calculate the impedance of the circuit, so what is the formula of impedance in RLC series circuit? It is Z equal to root R square plus XC minus XL whole square. XC minus XL whole square. Now we have to put all the values. So Z is equal to root, what is R? R is 40. So 40 square plus, what is XC? X is 91 minus 61 whole square. So we get here 40 square 1600 or plus 91 minus 30 square. 30 square is 900. So it get 2500. So final answer is what? 50 ohm. This is the impedance of the circuit. Clear to you? But one more thing is also asked in the question, which is what? You have to calculate the power factor of the circuit. And power factor is what? Cos phi. Cos phi is called power factor. So we write here power factor of circuit is cos phi equal to what? R by Z. This is the power factor. What is R? Resistance. And resistance of circuit is what? 40 divided by impedance 50. 0 and 0 cancel. So phi equal to what? Cos inverse of 4 by 5. And what is the value of 4 by 5? It is equal to 37 degree. This is the power factor phi. Clear to you? Now we have to discuss last question. And last question is what? An object of height 3 mm is placed at a distance of 40 cm in front of concave lens. Of focal length 21 cm, find the position, nature and size of the image. Position, nature and size of image formed. Okay, we have to discuss this question. Question is this: focal length given, object distance given, and height of the object is also given to you. So we know that here, what is the object distance? U minus 14 centimeter, because light rays incident like this, and distance is measured from the optical center in opposite direction. What is the focal length of the lens? This is plus 21 centimeter, because focal length of this lens is always positive. Now here we apply the lens formula, 1 by f equal to 1 by v minus 1 by u, and this is 1 upon f plus 1 upon u is equal to 1 upon v. So we have to taken the LCM, u into f, uf. So this is f and f cancel, u plus f is equal to 1 by v. So what is the value of v? We write here uf upon u plus f. We put all the values in this question. What is u? U is minus 14 multiplied by f is 21 divided by u minus 14 or plus 21. Clear to you? So we have to write here v is equal to minus 14 into 21 divided by minus 14 plus 21. So this is plus 7. Clear to you? Okay. U plus f, or u plus f is, u is this 21 minus 7. Clear to you? Okay. Now we have to write here 7 to the 14. So v equal to minus 42 centimeter. And v is negative. So image is what? Virtual. In this situation, image is virtual. And you also think theoretically, when object is placed 14 centimeter, that is just away from the focus. Focus is here and object is placed in between optical center and focus, then virtual and direct image will form. virtual and erect image will form. Now you have to also calculate the magnification. So m is equal to v by u. M equal to v by u. And what is v? V is minus 42 and u is minus 14. So you have to put the value minus 42 divided by minus 14. This is cancelled. So this is 3. Magnification is what? 3. And the size of object is given. So we have to calculate height of image. Height of image. So m equal to hi divided by h naught. Hi divided by h naught. So m equal to what is hi, height of image? You have to calculate h naught. H naught is 3 and this is m. M is also what? M is also 3. M is also what? 3. So on multiplying, height of image is equal to 9 mm. This is your final answer. Clear to you? Minus 42 m equal to v by u. And we have to put the value of v by u. So v and u. So it is 42 by 14. This is plus 3. Plus 3 is what? Virtual image. Clear to you? If m is positive, image is virtual. M is negative, image is inverted. Okay. This is virtual and erect. So virtual and erect image will form. This is your final answer. So we have to discuss all the complete paper of first preparatory of PU exam. Clear to you? First, please subscribe the channel and share with your friends. Now we meet in next class. Thank you.